In this lesson, I'd like to discuss the phases of the moon and eclipses, both lunar and solar eclipses. First of all, let's remind ourselves of some important terminology. The first thing is rotation. Remember that rotation is when something spins on its own axis. Notice that this is the moon here spinning in the exact same counterclockwise orientation that the Earth spins. Then we've got the revolution, which is moving around a central point. And in this case here, we have the Earth and the moon is going around the Earth. The reason that there's a dot on the top here is because I'm trying to show you that this is the North Pole. So if we were to look straight down on the North Pole, we might see the moon going counterclockwise around the Earth this way. But if we were to look at it at the equator view, looking at the side, you'd actually see that the moon is sometimes above the Earth, sometimes below the Earth. It's not always directly behind the Earth in relation to the sun. Okay? So that's going to be important when we talk about eclipses, to know that it's not, sometimes it can be above, so it can still get full light from the sun smacking into it. As the moon revolves around the Earth, there are different amounts of sunlight that seem to reflect back to us, and anyone who's on Earth will see different amounts of the moon visible. Those stages are called the phases of the moon, but it really just depends on your perspective on Earth. So for example, let's say you're standing here looking at the moon right as it is here with the sun in behind it. You can see in each of these pictures that the moon is always half lit up by the sun, and it always has this part in shade and the part that's lit up. But depending on what you're looking at, if you're standing here looking at the moon when it's in between you and the sun, you're only going to see this dark half, the shaded half of the moon. And this is what we call a new moon. And if you look down below, you can see this is the perspective of that person that's on Earth. New moon, mostly in darkness here. Then, as the moon begins to revolve around the Earth, now you're going to be seeing different parts of it. Notice that there would be this slight little sliver on the right that we would see, and it would be lit up. And this is what it ends up looking like, what we call a waxing crescent. The crescent is just the name of the shape. So gibbous would be when it's more than half full of light, and crescent would be when it's less than half full of light. But the waxing and the waning part are referring to whether the light is getting greater, and you can see in each picture that we're getting more and more light until we hit full moon. And then waning is telling us that the light is disappearing. That we're getting a darker and darker moon, and then we'd start right back again at new moon, as you can see from the cycle above. So at point 1, we see new moon. At point 2, we're going to see the waxing crescent. When we hit 3, stage 3, you can see that just half is in the darkness here and half is in light from this person's perspective. But it's called the first quarter because if you imagine that you're going in 1, 2, 3, 4, you've got this being the first quarter, if you can imagine this big circle being chopped up. So we say this is the first quarter of the moon's orbit around the Earth. Okay, some people do call it half moon, but the moon's always half lit. It just depends on your perspective. So quarter moon is the best way to describe it. This would be first quarter, and this would be last quarter. Okay, then you move here, you can see it's from this person's perspective, it's mostly lit up, a little bit of dark on the left. And then here we have it fully lit up from our perspective. And then it starts to go the other direction. Now we're going to get darker and darker as we wane, as the light wanes. So here we have a little sliver from this person's perspective on their right, and the moon is lit up on the left. And then dark on the right, and then again from the person's perspective on Earth looking this direction. And it would be light on the left. And then it would be mostly dark, a little bit of light on the left, and back to new moon here. And that, of course, is the same as what's happening down here. So as we go from 5 being this one right here, the full moon lit up, then we see that on the right, it's getting a little bit darker. And again, from the person's perspective on Earth, it's getting a little darker with lots of light on the left, lots of light on the left, and so on and so forth. The way that I can remember, obviously the crescent shape and the gibbous is not that hard to remember, but the way that I remember waning and waxing is I put these words in alphabetical order, waning, N first, then X. So I do left and right, waning, waxing. And then I say these little phrases for myself. Light on the left is leaving. So if you see the light on the left here, then you know it's going to be getting darker and darker day by day. Whereas if it's light on the right, it's getting bright. So here's the light growing on the right. It's getting brighter and brighter and brighter. So I know that these guys, light on the right, must be waxing. And then these guys, light on the left is leaving, so they must be waning. And that's how you can remember these different parts here. Now keep in mind, when we say dark side of the moon, if you've heard that before, it does not refer to the shaded part or the part that's in shadow. It refers to the part of the moon that we actually never see from Earth. The reason that we never see that part from Earth is because the moon always faces the Earth in the exact same orientation. Why is that? That's because the moon's rotation, if you look down here, the moon's rotation, its day, is exactly the same length as its year. If you were to move around, you would always be facing towards the Earth if you spun at the same speed that you were rotating. There's a video on our YouTube links in our classroom that you can go take a look at, and it does a nice job animating that for you to help explain it. Keep in mind, again, you have to memorize this number here. It takes 29.5 Earth days to go from one cycle of the moon. So let's say we started at new moon. It would take 29.5 days for us to see the new moon again. Also in the video online, you can see that that's not how long it takes for the moon to go around the Earth. That's 27.3 days. But for us to go from one phase to the next phase, new moon to new moon, or full moon to full moon, or even first quarter to first quarter, it takes 29.5 days because the moon isn't the only thing that's moving. The Earth is also moving. And again, there's a great animation in the video online that I'd love to have you guys go and watch. Okay. So another couple of things to remember. Again, as I said at the beginning, that the moon actually goes around the Earth at an angle. Okay. Now, sometimes keep in mind that you've got this sun shining and you've got the actual celestial bodies, both the moon and the Earth, have a shadow created behind them. When the sun's rays come right and hit them, there's always a shadow behind it. Now, on the Earth, we would say this is night on Earth, and of course, this would be then technically night on the moon as well. But the elongated shadow can actually influence one another. When the moon is either below or above, it doesn't fall into Earth's shadow and it doesn't cast a shadow on Earth. But when they are directly in line, then there is a shadow that is cast on the Earth, and then there is the Earth as well can cast a shadow on the moon. And when that happens, we have something called an eclipse. Now, an eclipse is when something gets shaded out. So if it's a lunar eclipse, then it's the moon that's being shaded. And if it's a solar eclipse, then it's the sun or the sun that's being shaded. Okay? So when you are in position C right here, and the moon is behind the Earth in relation to the sun, then it falls, and the Earth's shadow will fall on it, and it will eclipse the moon, lunar eclipse. And if it's the moon that's in front, in between the sun, notice that it's only a small portion on Earth that will actually see the full eclipse. And we'll talk more about that in the video that you're going to watch online. Now, there can be total eclipses, which means that you completely block, and you can have both a total solar eclipse and, if you look down here on the right, a total lunar eclipse as well. But you can also have partial eclipses, which are way more common, and an annular solar eclipse. Annular in this case, doesn't mean every year. Annular in this case means it forms this ring because the moon doesn't perfectly blot out the sun the way it does over here so that you can see the corona and the chromosphere. So why would we ever have anything that's kind of like a partial eclipse? Well, because there's two types of shadows that actually end up happening. The darkest part of a shadow is called the umbra. You'll cover more of this in grade 10, but the umbra is the darkest part of a shadow because it doesn't matter what direction the light's coming in, no light reaches this section. Whereas with something like up here, when you have the sun that is so large and sending out rays in so many different directions, yeah, there's this dark umbra part, but there's going to be a little bit of light. When you have the light coming and hitting the moon this direction, you'll have a little bit of light blocked, but it'll still be lit up by this side. So you'll have a partial shadow where it's only getting half the light, and that's exactly what an umbra is. A penumbra is a partial shadow. So you get some light coming in this side, so it's not completely dark, but you do block the light from the other side. Okay, so umbra, total full shadow. Penumbra, partial shadow. So when we look at these eclipses here, we can see that you got a nice bright full moon right before this amazing lunar eclipse. And as soon as the full moon moves into the penumbra, you can see the only difference is that it darkens just slightly. It's still being lit by part of the sun, just not the entire full force of the sun, because it's in a partial shadow. It's in the penumbra. And then as the moon begins to move into the umbra, you can see that this is dark, 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 and this is still partially lit because that's the umbra section and the penumbra section. And then as it moves completely into the umbra, so there's no light from the sun actually passing and hitting the moon, it turns into what we call a total eclipse. And because of its reddish color, we call it a blood moon. And again, why does it suddenly go red? Well, it goes red because of the way that light is being refracted. But again, that's explained in the video that you're going to go and look at shortly. Okay, so remember these terms: umbra, penumbra. Umbra is the full shadow, it's the darkest part. Penumbra is that partial shadow. There is actually one total solar eclipse about every year and a half, every 18 months. But because of the way that the Earth is spinning and the different locations that we are in the different seasons around the sun, we're not always able to see it. Only some parts of the Earth can see it. Sometimes, depending on exactly where you are, what location you are at, you can have it last for several hours. But sometimes it's only a few seconds that it's completely dark. Totality means completely blocked. So it may take some time for it to move across the sun. So in other words, the moon itself is moving in between us and the sun. It takes time for that to happen, and that can take hours. But this actual total solar eclipse moment doesn't last very long at all, just a few seconds, and then it begins to move off again. But it is quite amazing, and I hope you got to see it a few years back. Another important thing to know, every solar eclipse is going to happen during a new moon. Why is that? Well, if you go back up to our picture here, you can see this is a new moon. Notice that the moon is on the darker side. And this is when the moon is between the Earth and the sun. A new moon. So that's the only time that the moon could ever block the sun. If it's a little down or a little above, it's not going to block our view of the sun during the daytime. So every solar eclipse happens during a new moon, and then every lunar eclipse happens during a full moon. Okay? So when the moon is behind the Earth and in relation to the sun, and the Earth can cast a shadow on the moon, then you know you've got a full moon and it'll be the lunar eclipse. Now again, it doesn't happen every single time. Not every new moon is a solar eclipse, and not every full moon is a lunar eclipse. And again, that is because the orbit of the moon around the Earth is not always in line with the sun. It's at this angle here. So sometimes it's a little too high, sometimes a little too low, and sometimes it's just right to cause a solar eclipse or a lunar eclipse. It has to be in line at just exactly the right moment. There's a little link that I've put in our classroom where you can go if you're interested to look at when the next lunar eclipse will be and solar eclipses and whatnot. Also, the dates are listed here, but just in case you're watching this video after May and June, you may want to go and take a look at that site on our school website. Here's some random facts for you. The word month actually comes from the word that means moon. And once upon a time, honeymoons used to be a month long. So husband and wife would get a month away together, not having to serve in the military or not having to work, and family would take care of them for that month. Pretty good deal. Now we get, what, a week? 10 days, if you're lucky? Lunar also means moon, and the word lunatic is what we call someone who is determined to be crazy. And the idea is that they used to believe that maybe the moon influenced their behavior, so they were crazy because of the moon, lunatic because of the moon. Right? A blue moon, if you've ever heard anyone say it happens in a blue moon or once in a blue moon, this is when you have a full moon, but you have an extra full moon in a month. So let's say on January 1st you had a full moon, and then on January 30th you had the next full moon. That would be 2 full moons within one calendar month, and it doesn't happen all that often. So once every 2.5 years you have a blue moon. Once in a blue moon means once in a while. You have a harvest moon as well, if you've ever heard of that. It's a full bright moon. It's the brightest moon that occurs closest to when people are doing their harvesting. So for us, the start of autumn is September 21st. And farmers used to depend on that extra moonlight to help them get their crops in before it got too cold. So they would take advantage of that extra light. So harvest moon is being able to work later in the evening with a nice bright moon lighting your way so you can still sickle your crops. Okay? A blood moon, we already mentioned this, is when you have a total lunar eclipse and it looks red. And again, you can go back and take a look at that picture. Supermoons and micromoons are not just visual tricks, although there are some light bending tricks that happen. But a supermoon is when the moon is actually larger because it's closer. We call this perigee. When the moon is at perigee, it's about 360,000 kilometers away from us. When the moon is at apogee, which is its farthest away, it's about 405,000 kilometers away. And so we call that a micromoon. Supermoon, micromoon. Closest to us, farthest away from us. Please know these terms, perigee and apogee. And that, my friends, is the end of this lesson. Please go to our classroom and take a look at the videos I've posted there. You can go to Content, go to the Space Unit, go down to the YouTube links, and then scroll down to today's lesson, where you see Lesson 4, Phases of the Moon, Eclipses. And please watch these 2 videos here. That'll really give you some good visuals for what we've just talked about. Also, make sure that you've taken a look at the homework that's listed in the unit outline. The gizmos that you're going to do are going to be very helpful to help explain the phases of the moon and the eclipses.